All right, guys. First video of the new year. Okay, we're going to have a brief review of linear algebra. Like I told you in class, this stuff's pretty important. In all higher math, you got to be able to work with linear algebra on demand, and it's easy stuff. Okay, so you end up in this situation a lot in some of these calculus textbooks where they talk about some object or particle or whatever moving from point A to point B. Now sometimes these particles or objects move in a straight line. Sometimes they don't. If they do move in a straight line, then obviously we can talk about the slope of that line, assuming that it's a non-vertical line, because if you remember, vertical lines have slopes that are undefined. So assuming it's a non-vertical line, if we move from point A to point B, we can calculate the slope just by doing delta y over delta x. I know some of you might still remember it as rise over run. So if we go delta y minus delta x, as long as you're consistent, with how you subtract. So notice we're going ending point minus beginning point. So I'm going y sub 2 minus y sub 1. So if I'm doing delta y, ending point minus beginning point, then I have to do delta x in the same order. I have to go x sub 2 minus x sub 1. So as long as you are subtracting in the same direction with both delta y and delta x, it'll give you the same answer. It doesn't make any difference. Easy stuff. That's slope. You've been seeing that since you were in junior high. Okay, so the formulas, and I know you probably haven't seen these since you were in geometry and we reviewed linear algebra. This guy right here, the point slope, sometimes they call it point slope equation, sometimes they call it point slope formula. It doesn't make any difference. But this guy is like your Swiss Army knife for linear equations. So we're going to use this guy constantly. And then these are like your two general forms that you work with. We have our slope-intercept form where y is isolated. And when y is isolated, on the other side, the coefficient of x is always your slope. So the little m is always your slope. And the number being added or subtracted to x is always your y-intercept. It's where the line crosses the y-axis. So hence that's why they call it the slope-intercept form or slope-intercept equation. And then what I normally refer to as standard, sometimes is referred to as general. So these guys go interchangeable. So if it's in that form, we're going to have the term with x and the term with y both on the left-hand side and a constant on the right-hand side. And all of these numbers, a, b, and c, all of these numbers have to be integers. So obviously a, b, and c are elements of the set of integers. Remember, capital Z is your set of integers. So we can't have any fractions or any decimals there. So we'll do both of these guys. We'll use this guy to begin writing the equation, and we'll put it in both forms. So pretty typical situation. Matter of fact, I put you in this situation a number of times in geometry. So we have a line that goes through these 2 points, and we want to write the equation, and we want to express that equation in both slope-intercept form and general form. So the first thing I have to do is find the slope. Very first thing. So remember, your slope is always going to be delta y over delta x. So when I'm calculating my slope, I've got to make up my mind. Do I go the coordinates of this first point minus the coordinates of the second point, or do I go the coordinates of the second point minus the coordinates of the first point? And it doesn't make any difference. It'll give you the same answer. It's just a matter of staying consistent. So I'm going to go I'm going to go the second minus the first. So my delta y is my numerator, so I go 0 minus a negative 9. Which means I have to go 7 minus a negative 1. So that's going to give me 9 over 8, and that is a reduced fraction. Okay, so my slope is 9/8. Okay, all right, so I'm going to start with my point slope formula. Y minus y sub 1 equals the slope, little m, times x minus x sub 1. Okay, so when I do that, I have to use this as my slope. Okay, so the slope is 9/8, and my point, okay, I have to either use this guy or this guy, and it doesn't matter which one you use because it's going to give you the same equation. If I'm given a situation like this where one of the points has 0 as one of the coordinates, I always use that guy because it usually ends up being easier. So if you want to use that point, go ahead. I'm going to use this guy. Okay, 7, 0. And so we substitute in. Okay, so y minus y sub 1, which is 0, equals the slope, 9/8, times the quantity of x minus x sub 1, which is 7. Now notice this y minus 0 just becomes y. And then notice I distribute here, so I'm going to get 9/8 x minus, what will they give me, 63/8. Like that. Okay, and this right here is your slope intercept form. Now, how do I know that slope intercept form? Because on the left-hand side, the y is all by itself. Okay, so if y is isolated, that's automatically slope intercept form. Okay, so I know the slope of the line is 9/8, which I already know, and I know this line goes through 63/8 on the y-axis. That's my y-intercept. Okay, so that takes care of slope intercept form. Now I want to go to general or standard form. Okay, so I have to get rid of all the fractions at some point. Okay, so I'm going to get rid of them right from the get-go. Okay, so if I want to get rid of these two fractions, I have to multiply through by the least common denominator of the two fractions. And since the two fractions have the same denominator, obviously the least common denominator is 8. So I'm going to multiply all the way through by 8. So 8 times y equals 9/8 x minus 63/8. Okay, so let's see. It gives me 8y equals 8 times 9/8, the 8's cancel, so I just get 9x. 8 times 63/8, the 8's cancel, so I just get 63. Okay, so to put it in general form, now that I've gotten rid of all the fractions, I need the term with x and the term with y both on the same side. I always like to put them on the left and a constant on the right. So if I take the 9x and move it over, it becomes negative. So I get a negative 9x plus the 8y equals a negative 63. Okay, and that is my standard or general form. Okay, so let's see. Well, we've got everything done. Okay, so we're good. So those are my two possible widely accepted forms of the linear equation. Okay, let's try one more. Okay, so let's see. Same type of problem. Okay, now what I really like is this guy right here. Because notice that 0, 11. That point is on the y-axis, which means it's going to make my life easier. Okay. All right, so let's see. Let's do the slope first. So remember, it's delta y over delta x. Okay, and let's see. I'm going to go these coordinates minus these coordinates. So delta y would be 11 minus negative 8. And delta x would be 0 minus 3. So I'm going to get 19 over a negative 3. And of course, we don't like negative signs in the denominator, so I'll just put that up above. So I'll use it as negative 19 thirds. Okay. Now the good thing here is that is my y-intercept, which means that's my b. So instead of going to my point slope formula, I will go right to my slope-intercept formula. Okay, so I'm going to use y equals mx plus b. And I already know my slope is a negative 19/3, and my b, well, that's my y-intercept. Okay, so my b is 11. So all I have to do is just punch it in there. Okay, and so we get y equals negative 19/3 x plus 11. And there's my slope-intercept form right there. Now, if you did not notice that this guy was your y-intercept and you went and used your point-slope equation, it'll still work out and you'll get the exact same form. You would get the exact same thing. So it doesn't really make any difference one way or the other. Okay, so let's see, we've got to change that to standard or general form. So I'm going to get rid of the fractions first. Well, there's only one fraction, so the least common denominator is 3, so I have to multiply through by 3. Just multiply through, so I get 3y equals, notice the 3's cancel there, I get a negative 19x plus 33. And then bring the term with x, move that over, so negative 19x becomes positive, so I get 19x plus 3y equals 33. And so that's your general or standard. It doesn't make any difference what you call it. It means the same thing. So general form or standard form. Okay, so pretty easy stuff. Okay, real straightforward, not hard at all. Okay, so let's see, horizontal and vertical lines. Run into these all the time, and these are the easiest equations in the world to deal with. Okay, so hopefully you guys maybe remember a little bit about these. Okay, so if we look at vertical, okay, vertical lines, or equations of vertical lines, I should say, only have an x variable in it, that's it. So it's going to be x equals some number. Okay, that's it. Okay, x equals some number. Now that right there ends up being the x coordinate of all the points on the line. Because if we take any point on this vertical line, the x coordinates will all be the same. So that's why we just describe it as x equals whatever the x coordinate is when it's a vertical line. Okay, if we look at horizontal lines, okay, we're going to get an equation y equals some number. Okay, and that number ends up being the y coordinate of all the points on the horizontal line, because if we take any point on this horizontal line, they'll all have the same y coordinate. So that's just the y coordinate. That's all it is. Okay, so let's go back to vertical, and you take a look here and say, okay, what are the coordinates? And I just chose 3 random points there. You could choose whatever points you want, as long as they're on the line. It doesn't make any difference. Notice this guy is 7, 1. Notice this guy is 7, 3. And notice this guy is 7, 5. And notice all 3 of those points, because they're all on the same vertical line, they all have the exact same x coordinate. So we just say the equation is just x equals the x coordinate, which is 7. Up here, okay, I again chose 3 random points on that horizontal line. Okay, it doesn't matter which 3 points I chose, I just chose those. Okay, so notice this guy is 2, 8. Notice this guy is 4, 8. And notice this guy is 8, 8. Notice once again that all of the y coordinates are the same. Okay, so the equation of a horizontal line would just be y equals whatever the y coordinate is of all the points. So the equation is y equals 8. Okay, it's that simple. Okay, look at how simple horizontal and vertical lines are. Okay, probably the number one thing you have to remember is the X goes with vertical, the Y goes with horizontal. I get students all the time that get those mixed up, so you got to keep that straight. Okay, and I don't even need a graph. You know, if we take a look in here and we say, okay, what's the equation of the horizontal lines that go through these points? And then what's the equation of all the vertical lines that go through these points? Well, we know horizontal is y equals, so it's just going to be y equals, y equals, y equals, y equals. It's y equals the y coordinate. So it'd be y equals -4. That's a horizontal line that goes through that point. It'd be y equals 0. That's the horizontal line that goes through that point. That's actually the x-axis. That would be the equation of the x-axis, y equals 0. This right here would be y equals 3. And this right here would be y equals -7. It's that simple. Okay, now vertical lines that go through all those points. Well, we know vertical lines, it's x equals always. And it's just x equals the x coordinate. So it'd be x equals the x coordinate. So x equals 5. Nope, and I have no idea how that ends up being a 5. Okay, so we get x equals 5. We get x equals -12. Okay, horizontal line here would be x equals 8. And here would be x equals 0. And x equals 0, that's the equation of the y-axis. Okay, so real simple stuff. Okay, so I'm going to shut this video down. Keep it short. I'm going to try to keep them all short. I'm going to shut this video down for now, and I'm going to make a second one for the second part of the notes.